So, ladies and gentlemen, this is about a giant leap in line with a bold vision that we have coined a couple of years back, actually several years ago. It's about 5G Future X, and it's happening, right? Giant leap, we are in the air, I should say probably on the air. In many key markets, we're actually building these systems, including the United States, Korea, China. So it's truly happening, right? This is a moment in time where 5G is happening. And what I'd like to explore with you all as we walk through this 20-minute session is how this may open up an opportunity across sectors, but particularly also for the automotive sector. And maybe to say one or two things up front, 5G is more than radio. 5G is more than radio. And second, 5G is more than any of the previous Gs in a variety of dimensions. And probably that's also something I'd like to discuss more as we walk through this session. So as to get warmed up, giant leap, and maybe some of the key dimensions as to why this would be a giant leap. Now this is high-level view, and you could add probably a long list of 20 performance attributes in a similar fashion. So it's about users, it's about connecting billions of sensors. Now these numbers are indicative. It's about speed in the sense of both upload, uplink, and downlink. Speed also the sense of how do we truly cover indoor and outdoor and all the way to the edges of the cells. Very important. Latency, that's a big one, maybe an iconic performance attribute associated with 5G. What is latency about? You all know what latency is? It's about real-time behavior, right? So if I were to throw this to you, Sandro, like the clicker, the latency response you would show out of the human system is something like, well, Sandro is a fast guy. It would be like 20 millisecond, I guess, kind of response, right? So just to put things into perspective. Now, if you want to do truly haptic, challenging stuff, like industrial robotics or scenarios associated with cars, autonomous driving as an example, you need to go lower than 20, probably into the range of 1 millisecond and below. And here's the great news. Can we do this with 5G and 5G evolution? The answer is yes. So latency, another key performance attribute. Then, I guess, another very important thing, and linking into the business model, not just the architectural side, and we'll talk architecture more, it's truly about flexibility, and therefore it's a regime that a paradigm shift towards, if you like, committed SLA, service level agreements, in ways we have not seen before, right? And this links into architectural elements, again, going way beyond radio, going into this dimension of truly softwareizing the entire architecture. And it links into, for the architects in the room, into this notion of actually slicing, of flexibly building virtual network on top of logical network. And we can do many slices, right? So if I just got back from New York, Bell Labs, so if you talk to some of the research guys, they will tell you, yes, can we do 100 million or million slices? Sure, we could do it in theory to the degree it makes sense. So there's no limit to how you virtually cut this if there are scenarios where this will make sense. So one more piece of level set. I think you're all aware of broadly the endless possibilities as clustered into 3 families of use cases. So this is meant to be a quick recap. These use cases would be broadly clustered into mobile broadband, massive machine, and then of course mission critical. And mission critical is where URLLC kicks in, so ultra reliable, low latency. And by the way, this has come a long way in terms of execution, and yet, now I'm a telco guy as well as serving enterprise, but from the telco side of the house, that's of course where we've seen the first key drivers of uptake, and the operators, so the ones who are now building out these systems, what is the one business case they really know? It's mobile broadband. There's nothing wrong with that, but the point is, there's a lot more to come, a lot more opportunity in conjunction with, broadly speaking, massive devices, IoT, and of course, mission-critical scenarios. Now let's talk technology briefly, building blocks. So it starts with new spectrum, right? And new spectrum is exciting because the higher you go in spectrum, the more bandwidth you can potentially allocate, and this therefore allows you to really increase throughput to hundreds of gigabit per second, right? And when you look at Nokia portfolio at this time, like AirScale radio platform, once you stack some of these baseband modules, can we build a terabit per second base station? Yes, we can. So this is really a powerful shift, and it goes way beyond vision. It links into technology building blocks such as massive MIMO and beamforming, again, by the way, an element of software. It links into the notion of flexible air interface, right? And that's part of the promise. It links into the notion of multi-connectivity, and I think that's very important also. So dual connectivity, 4G, 5G, but also linking unlicensed bands into this. Think CBRS in a smart way, shared access, sharing spectrum, and of course also Wi-Fi. Why not? For the use cases where it makes sense, where you don't need the attributes of 5G, such as latency or reliability. I think very important here is the fact that this is also about cloud native transformation. So when we say cloud native, what does it mean? It's about virtualizing infrastructure, software defined networks, but also is about this notion of going shared data layer in conjunction with flexibility, flexible attributes, linking into automation and cognition, and therefore slicing. And maybe one last, so as to truly connect billions of sensors where many of these sensors might not be on all the time. It's more bursty kind of traffic. That's where connectionless kicks in. So with this, a quick look at the architecture, and I'll be brief, and yet I think this is important because some of these themes, when you look at the early morning session, kind of link into what you've seen from the automotive sector perspective, and yet they do go beyond. So what you see here on the lower part of the chart actually is a visualization. Is a visualization of future architecture vision. What you can see here, broadly speaking, is 8 architectural domains, right? 8 architectural domains. And as you can tell, this goes beyond devices and massive scale access. It goes beyond radio. Now, radio is very important, and of course, devices and billions of sensors certainly are. But then there's a whole story of flexible differentiation and empowering digital value platforms in ways we haven't seen before. And this links into domains, including the converged edge cloud, including smart network fabric, right? How do you smartly not only optimize the radio side, but truly the transport, end-to-end performance, right? And then linking into what truly is the cloud-native parts of the architecture in conjunction with machine learning, AI, and of course attributes of security. So very powerful paradigm shift, and all this actually then links probably into 4 dimensions of leapfrog and change. The one, and the journey goes on, radio access networks. So I just got back from Bell Labs in New York. We have Bell Labs facilities also here in Munich and Stuttgart. So in case you're wondering what is that folks are working on at this time, are they working on frequency range up to 90 gigahertz or even higher? Yes, they are. So stay posted, terahertz bands, we will leverage these for the use cases where it makes sense, especially indoor, industrial, just to mention this. Cloud native journey keeps going. So it's clearly also maybe to highlight one thing about open platforms in conjunction with attributes of scalability. And then maybe one thing I haven't heard this morning in the transformation discussions on E2E architecture, probably, ladies and gentlemen, it's also about the process. It's about continuous integration and development. It's about DevOps, development operations paradigm. That also is what we drive actively, aggressively with many of the customers we serve. Another attribute of cloud nativeness. Then, I guess, very exciting in terms of both time to market as well as efficiency gain is this aspect of automation. And of course, linking into a notion of slicing, excitingly enriched, last but not least, by embedding machine learning and AI into the architecture. I think we had some good examples of this yesterday, relevant for automotive, truly pervasive across the architecture. Now with this, let's look at the timeline a little bit. And I'd like to share with you all timeline 2018, 19, 20, but all the way out to 2030. So it starts with spectrum availability. And what you see on this chart, actually it's good news. Why is this good news? When you go back like 2 or 3 years in history, there was a lot of concern, at least among the telco players. What was the concern about? It was about spectrum fragmentation. Right? There was a risk that folks in different geographies would allocate different spectrum bands, and from this we would end up with a huge degree of variance of spectrum. Good news is, didn't happen. What you can see here on the chart, and this is true across the planet, including the United States and Europe and China, Japan, we see a pattern of spectrum allocations for 5G and 5G evolution, including at the very low end, 600, 700 megahertz bands, and then of course 28, 39 gig. not to mention the unlicensed bands that now increasingly also are being made available. In case you haven't heard, FCC actually just allocated test licenses for the higher frequency bands, even 90 gigahertz and above. So it's happening. Use cases, scenarios. It has started, remember the journey had started with fixed wireless last year. That's where we rolled out the first systems, 5G. Now we are right in the middle of rolling out what we call NSA. No, it's the other NSA, non-standalone solutions. And this is, of course, what is NSA about? It's about basically plugging 5G radio into what otherwise is 4G architecture, so evolved packet core. Nothing wrong with that as a first step, but I think the exciting opportunities truly will come with 5G core and standalone. Why? Because this allows you then to go bearer independent and go for the full flexibility in terms of quality of service, right? Truly going flow-based, IP flow-based. That's the true potential. And here maybe one more piece of reflection on 2018. 2018 has been a crazy year in many ways. We accelerated. Like the industry with 5G, we accelerated. We accelerated 5G new radio standardization, as you may recall. We did it, contrary to what many folks thought. It has been done. The other great piece of news is not only for new radio, but also for the 5G core part. So now I'm talking 3GPP standardization. This is very relevant, very important, especially for industrial and also automotive context. Why is it important? Because with the 5G core also being standardized as part of Release 15, we are now ready to do all these exciting new things, including flexibility scenarios, linking into slicing, virtual networks on top of logical networks. Now let's look at 2019. Pretty exciting year. We are right in the middle of this. Let's look at 3GPP, 5G Phase 2, Release 16. And maybe before we look at some of the key items on that chart, there's another very encouraging piece of news. When you look at the system architecture, the requirement set discussion, right? Historically, it used to be the operators, the Deutsche Telekoms, Telefonicas, Vodafones of the world, jointly with the vendors who had driven 3GPP. And you're all aware of that. So what has changed? What has changed is, and this is very significant, ladies and gentlemen, it's encouraging. What has changed is that increasingly industrial players, automotive players engage in 3GPP. Right? So what we've seen is on the system architecture level, service requirement level, 39% of all requirements come from enterprise vertical players. This is great news. Why? Because any operators in the room? Well, so I can say this. Operators might not really know about automotive, not really know about industrial automation, but many companies in this room do. Right? So this is why it's great to have active engagement from enterprise so that we get the standard right. And actually that's particularly true also, and this is the one area that I think is of special relevance when you look at Phase 2, Release 16 standardization, V2X, V2I, V2V, including what we call new radio site link discussion. It's a work item. At this time, we are still working on architecture and concepts. We are working on this, by the way, in a pre-competitive fashion, and that's cool. Right? So what's happening is out of Bell Labs, we kind of say, okay, here are the cool ideas that we believe in, and then we discuss with operators and also other vendors, are these truly the winning ideas, the best ideas, and then hopefully at the end of that process, we kind of agree on what the specification should be. So that's the standardization piece. Powerful, encouraging, and yet, maybe one more thing I'd like to mention. Increasingly, the ecosystem we are talking about also goes beyond 3GPP. Right? And we at Nokia have always been passionate about it. What I mean by going beyond is going open in terms of leveraging open source paradigm with faster time to market, innovating in ways where you don't need to wait for consensus. Where also you could argue we don't need to come up with all these options like 3GPP does. So interesting opportunity also for automotive, and I'd like to have your view on this more. And of course, it links into this idea of building ecosystem. So it's more than a techie discussion, to be very clear. So let's give a quick look at assisted autonomous vehicles. And I think we've seen some discussion on this already. So what are the key drivers? Now, this is high-level view. I think, yes, it starts with avoiding fatalities and death. But I think it's truly, in addition to cost optimization also, potentially, it's truly also about user experience and enabling giving people time back kind of thing, right? So I think that's one of the aspects that's very relevant. And of course, it's also about why 5G. So some of you might have followed some of the debates, some of them educated, some of them not so educated as to why 5G versus other options like Wi-Fi. It's very straightforward. When you look at Wi-Fi, it's an option when you need bandwidth, right? But if you are interested in scenarios, and automotive use cases are scenarios like these, where it's about reliability and security and latency, Wi-Fi, just the way the protocol is built, doesn't give you that. Right? It's because of listen before talk kind of paradigm. So it's very simple. Wi-Fi doesn't give you that. Do we at Nokia also do Wi-Fi? Yes, we do. So ultimately, it's a discussion about context and use case, and there's nothing wrong to have like a Wi-Fi access point in the car, moving in the car, sure enough. But when it comes to mission critical, when it comes to security, sensitive application, 5G is the right choice. Not to mention also probably economy of scale benefits as now coming up. And then you see kind of a use case timeline, like from the first phase as we are now actively rolling out into the next phases, phase 2 now, standalone, URLLC and slicing. And there it's really, when you think about it, about flexibility, softwareization, and the advantages in terms of time to market, as well as automation and therefore cost efficiency associated with such approach. So market opportunity, I guess big picture, not just looking at automotive, we expect something like 3x type of growth opportunity across sectors, so from 1,000 billion to 3,000 billion type of opportunity if you add all the sectors up. Now a point number would be the 20 billion connected cars and industry revenue. But I think the interesting thing is that truly connectivity you can almost consider as a given, right? It's a building block we have in place. At the same time, as I tried to highlight earlier, the true discussion therefore need to go beyond basic connectivity. It's about leveraging context. It's about leveraging the various sensors you have in the car. It's leveraging these into the notion of cognition, artificial intelligence, machine learning, and then you can come up with use cases that go way beyond autonomous driving, even though, yes, this might be a lead case, why not? But there might be many others, right? And you could think of scenarios like your speedometer breaks and you have a smartphone in the car at the same time. Could the smartphone step in and take over speedometer function? Why not? Conceivable, right? When you talk to our research guys in the Nokia labs, Bell labs, they tell you we can do it pretty much now, implementing on the compute paradigm accordingly and the way we configure the network management overall. Can be done. So it's all about experience, and just very briefly, not just experience, but also ecosystem. So we at Nokia, we also have a strong passion to build ecosystem. This is a time of change and transformation. I think it's the opportunity, as said, to leverage what has historically been communications-oriented paradigm now into a various sector play, automotive in particular. And here you see some of the examples as we have done. And this ranges from alert messaging, like folks crossing the road, all the way to very accurate positioning. And by the way, in case you haven't noticed, positioning is one of the key benefits also that comes with 5G. Right? We have a variety of cool technologies by means of leveraging parameters as we get from interfacing with various edge clouds and or base stations, so as to improve efficiency to centimeter level, where that makes sense. So with this, to wrap this up, it's all about speed of innovation. It's about ecosystem building. It's about making it happen. I think increasingly we are now going beyond the early proof of concept stage. It's about making business decision. We at Nokia, we are passionate about it. Semiconductor, just to be very clear, that's why it's at the heart of this chart, are right in the middle of this. System on chip and not just the associated smartphones, but in particular also the various connected sensors, many of them in the car. I think this is very much part of the transition. It's part of the opportunity. And then, of course, automotive, you could also argue, might have potential to go beyond the connectivity play. You could link automotive into airborne vehicles, the stuff you're good at, leverage that into airborne context, right? High altitude platforms, satellite, why not? Some of the control software you're good with, conceivable. You could link it into ecosystems like seaports or airports, right? In these cases also you have moving vehicles, platoons, use cases that again potentially you can leverage 5G with, and some of the sector knowledge automotive is all about. So it's exciting, and we at Nokia are excited to work with you all on making this happen. With this, thank you all. Back over to you, Sandro.